Hello, everyone, and thanks for joining us for our monthly single store community call. We've got Akmal Chaudhry, there, our developer advocate, and Carl Severa, senior director from our R&D Launchpad team. Welcome, guys. Maria's not joining us today, a little bit of laryngitis. We got a great 30 minutes of content for you to tell you a little bit about what's happening with single store around the dev community. I want to say that in today's program, we'll cover a few of the updates from our recent launch event. And also, I think the main event is going to be Carl talking through the WASM Space program, which is a demonstration application built as a game simulation to demonstrate some of the new capabilities in SingleStore. So that's really exciting, and he'll do a walkthrough of that for everyone to take a deeper dive. Um, so with that, I want to talk a little bit about what we announced back in July at the summer launch event. And I think for those of you who want sort of an intro and then deeper dive, a great resource is going to be our YouTube channel. So we've started to publish a series of videos on each of these, and they're going to keep coming here. But if you take a look at our channel here, you'll see that we've got a breakdown of each of the events. And I think most interesting to the community for developers here will be the dev track, which was our second hour of the event that ran in parallel with our business track that Oliver led. And so this track is led by Adam Prout, and we've got a full breakdown of the content. Adam starts with describing, how SingleStore is built uniquely to serve real-time applications and analytics, and gives you sort of the primer or cliff notes is how I think about it on each of the components of the database internals as to how it's built and how it's put together. So that's a great starting point. There are references there that take you to the Sigmod paper and take you to other deeper dive resources if you want to understand how each of these works. Secondly, Eric Hansen from the product management team covered a set of new capabilities that are just make development with SingleStore much easier. So there are utility functions in here. He calls them toys. I think that there's a blog article as well that I encourage people to take a look at. It's really going to help with the development there. Workspaces is a new capability that helps to isolate compute from storage and isolate compute from compute, as we say. Carl's going to touch on this in a moment because this is one of the new capabilities that he's implemented in the Web and Space program demonstration. So follow along with that. We've got a blog article that describes how this works, and we'll cover that a little bit deeper. And then finally, I want to highlight the code engine powered by WASM or WebAssembly. And so here you'll find a deeper dive into how to develop a WASM module. Carl will also touch on this and how he's applied it in this example application. So take a look at this video content. I think it's really a great thing to start out with as you're learning SingleStore and getting familiar with the product. Next, I want to draw your attention to the forum. This is at SingleStore/forums. And if you're new to SingleStore, this is a great place to start, create a profile, post your introduction. You can start following topics. We ask that you would introduce yourself here in the introduction section. We're continuing posting new announcements here. And with that, I want to sort of announce some of our new members who have just recently joined the community here. Chow Yu from Western Digital, Chris from C Data in the Netherlands. Thank you, gentlemen. Mitch from Headingham AI, Zach Helms from SAS, Franco Giglio from Publica.la. Franco, we've been chatting on Twitter a lot. Thanks for joining the forum. We've also got some one-year anniversaries. Nikhil Shetty from Apple, Garrett Kaufman from Blue Triangle, Andy Inkabal from IAX Cloud, and Prajwal Baliga from Morgan Stanley. Thanks so much for that. A few interesting other notes, our user of the month is Smart Shale. And our most interesting introduction, go check this out, from Ed Lance on Pacific Software and Data. Another resource that's, I think, good for everyone here to bookmark is our Developer Hub. In our Developer Hub, we're posting links to our GitHub repo, which is SingleStore Labs. You're going to find the repos that we talk about here in this session at github.com SingleStore Labs, as well as our MemSQL organization there. And you're going to find interesting content posted from developers like you in the community. And so I want to draw your attention to some of the more recent articles. Aaron Francis, in collaboration with Carl here, have developed a Laravel connector. And we're going to have Aaron on this community call actually next month to talk and go into detail about that. And Carl is here today to talk about WASM. And thirdly, Vedran Sindrick from an API observability company called Treble has written about his use of SingleStore and migration from RDS to SingleStore to power their API observability platform. So with that, I'd like to, Akmal, hand it to you to talk a little bit about some upcoming meetups.
Great. Thank you very much, Dominic. So let me just share my window here. Hopefully you can all see that. So the main update really here is the conference, which I'll be speaking at, which is actually Saturday. So I'm flying tomorrow. Long way to go. LA. We love LA. And so I'm going to be speaking about WASM, actually, just applying it to data science, machine learning, which is kind of a pet hobby of mine, an interest of mine. So I am very pleased that we have this capability now within SingleStore to be able to implement pretty much anything, I suppose, a wide range of algorithms, sandboxed, and have the ability to extend the core engine in a protected way, and that's just awesome. Okay, so if you're in the LA area, please come along. So it's SQL Saturday, LA. It's free. Okay, and I think, let me see if I can share the page there. There we go. You might be able to see it. Okay, the other key updates for this time is a couple of days ago, Tuesday this week, I did a webinar getting started with SingleStore DB. So it's going to be up on our YouTube channel as well. And I think for those of you who may be interested or maybe looking for a way to bootstrap, get started, that could be very useful for you. So I worked through an example of how we could use Spark and Kafka, and how we could build kind of a streaming application, global IoT sensors, and consuming that data into SingleStore using our pipelines capability, and that could be very useful for you. The other thing to mention is that next week, Tuesday evening, so if you're in the Raleigh area, many years ago I used to travel out there to RTP, so this will be my first trip there for a while. But we have an office based out there as well, and we are organizing a meetup around WASM. So this is actually going to talk through the WASM space program that Carl's going to give you a preview of today. So we're going to go into more depth in that next week. Okay, I think the updates for now. The other key thing I would say that I'm going to be working on some content as well, blog posts around some of the work that I've been doing, especially the data science, machine learning, and the WASM capabilities. I think it would be great to get these ideas down on paper and get them published. So expect those soon. Okay, so I'm on it, and hopefully you will get those published very soon.
Terrific, cool. Thank you, Akmal.
Thank you very much.
Yeah, so let's go. I'm going to share something in the forum, which was a recent, or you can share it here, Akmal, if you go to the CrossSupply and string split. This is a question that was posted in the forum, speaking of your SQL Saturdays. Oh, thank you, Carl. Let me switch here.
Oh,
There we go. This is what we're talking about. So, yeah, so speaking of your SQL Server talk in LA, this is sort of related. CrossSupply is something that is a function that you see in SQL Server. And this was asked recently in the forum. And Carl, if you want to tell us a little bit about what that function does and the situation you would use it, and then how you would solve this problem in SingleStore.
Absolutely. So this question came in from, I guess, Tamara B on the forums, and it's a really interesting problem, and it's something that with SingleStore you can solve in a really nice way. So the question was, how can we reproduce this idea from, it looks like they're using SQL Server. And so in this SQL Server sort of thing, they're using CrossSupply, which allows you to basically take a function which returns an array and then to sort of rotate the result. So as you can see, we have this table which has product IDs, which has the two values like 2829, 2908, which is a string with a comma between those two values. And using cross-apply with string split, they're able to return that row, the row 16, it shows up twice in the output with the one of the values, the first value from the string as the first call, or in the first row, and the second value from the string in the second row. So we can think about it as essentially breaking up that string into like a set of unique values or a set of values, and then rotating it so that we have one row per value. It's a very powerful paradigm if you want to do something like this, like split up a string and then do some analytical processing on top of it. So in SingleStore, we have a way to do this. And as you can see, there's some conversation in this thread. And the final result is Robbie, one of our engineers, talking about how we can do it with the table expression. And so in SingleStore, we have an operation called split, which returns an array, and I'll show that in a second, a little bit more detail. And we also have an operation called table, which takes an array and then does that rotation, does that cross-apply operation, which allows us to essentially, technically table just represents the array as a table of rows. And then when we join our starter table, so in this case, manual rule, with that virtual table of rows, we get the effect of cross-apply. And so if we jump over to, oh, I can't switch my tab, it seems. Okay, do I have to reshare? That's annoying. Okay, one second. I will reshare my entire window because I didn't realize that was the case here. Let me just move things around. Okay. So here's the split function. If you can put that on the screen, Dominic.
All right.
So yeah, so where we were at this forum post. I was just talking about this table and split function. So this is the split function, just to give you an idea. So split function takes in a string or a blob to split, and then sort of the separator that you want to split on, and it returns an array. And so this is the key thing in SingleStore. Any function which returns an array can be used with the table operation. So the table operation looks like this. It just literally takes in an array as its input, and it outputs essentially, you think of it as taking each element in that array and making it a row in a virtual table. So now we have essentially a virtual table. And when we go back to that example query, we're joining that input to that virtual table. And so it's a really powerful paradigm, allows you to do cool stuff. An example of what you can do is JSON to array. So like, let's say that you have a JSON object, like this array here, 1, 2, 3, and you use JSON to array, the function, you can essentially get back an array of objects. So, and then you can use that with the table function. So you can now take like a nested array in a JSON field, and you can rotate it to have one row per element in that array. So you can do really powerful sort of analytical processing sort of solutions using the table function along with any of our array functions. And this becomes even more crazy possible when you throw in WASM to the mix, which is going to be an upcoming feature in SingleStore where a WASM function will be able to return essentially an array, which you can then use the table function to rotate. And so you can build really powerful features using this.
What strikes me is this, Carl, is this kind of manipulation of the data in database makes me think like if you're a data engineer, this becomes super useful because you can ingest a lot of raw data in batch. You can ingest it from streaming data sources, and basically do the ELT kind of approach. load it, and then do the transformation in database. And these functions that allow you to change the orientation, parse and transform the content strings, data, etc., are going to be really useful functions that perform super well in our distributed compute and storage environment.
Yeah, absolutely. Imagine you have some raw data containing a bunch of JSON records, and you want to extract some array within each of those JSON records and then materialize a table from all of those concatenated arrays. You can trivially do this really efficiently using JSON to array and the table function, for example.
Cool, super cool. You know, a lot of these kinds of functions, well, customers ask us for these and we develop them. We also have a lot of compatibility with MySQL and Postgres in terms of overlapping built-in functions, data types. But often some of these ideas come from our engineers themselves and our team. And at SingleStore, we have a regular internal hackathon that we do to help, push the boundaries of new things. And we just recently completed that. And Carl, maybe tell us a little bit about like the ethos of that internal hackathon and give us a couple of highlights from that.
Yeah, so SingleStore has had hackathons be part of the company since the very beginning. I joined over 9 years ago, and I think there was a hackathon in like the first month I was at the company. It's a really important aspect of SingleStore, and hackathons allow us to give engineers the space to build without restrictions. Because when you're building a product with a roadmap, you have to make sure that you're always fixing bugs as you go and making forward progress and reducing technical debt and making a really production ready piece of software. And that's obviously something we want for our production database, but it sometimes stifles innovation. And it's really surprising sometimes how much innovation can happen in a very short period of time when people are released from any kind of roadmap restriction or sort of stability restriction. If they just say, how much can I sort of produce from as a prototype in the shortest possible time? And
Cool.
oh yeah, your second question was what are some cool things that we built in this hackathon? So in this last hackathon, we have a lot of really awesome projects, some of which are going to show up in the product at some point, which is really exciting. So I can't talk about those because that's part of our secret roadmap. But the things I can talk about are some of the projects that you could actually do yourself. And then also Akmal will share a project that's already live, which is crazy. Like the best situation ever is when a hackathon project goes live. There's actually 2 projects that are live. And actually, I just remembered one, and I'll show that as well. So the first project I want to talk about is a couple of engineers at SingleStore leverage our new SingleStore code engine, which do you want me to show like the docs on code engine? We can just, yeah,
Sure,
we can just
that'd be great.
do this. So in SingleStore, we have this thing. Oh, whoops, I have to be in a managed service. So in SingleStore managed service, we have this thing called code engine, which you can find on our docs right here, code engine powered by Wasm. And we've talked about Wasm a whole bunch already in this call. We've mentioned the word, and really what it is send SingleStore with custom logic. And we're using a sort of virtual machine runtime called WebAssembly to do that. And that's really all that matters about the Wasm aspect of this. The fundamental advantage to you and your business is that you can extend SingleStore with custom logic. So during our hackathon, a couple of engineers took advantage of that fact to prototype some features inside of SingleStore using Wasm very quickly, much quicker than if they had to build those features directly into the engine. And so some examples of that is that one of the engineers added XML support to the engine. So now you could actually ingest all of those things I was talking about with JSON, where we can do arbitrary unstructured JSON processing. With Wasm, you could basically take an off-the-shelf XML parser and sort of processor, compile it into Wasm, and basically provide yourself with a bunch of functions that you can immediately start using in SingleStore. And those functions get executed directly in code generation and query execution, which means that they aren't that much slower than a built-in. I mean, they're going to have a little bit of overhead, but it's not a huge amount of overhead. And so it's very realistic to build pretty complex, for example, unstructured text processing systems where you take in, or semi-structured text, where you take in large XML blobs and you basically process them and reformat them into optimized SingleStore tables. And now we can essentially do that entire workflow within SingleStore, which is really cool. Another example that came out of the hackathon was someone who implemented a bunch of post-GIS methods. So for anyone who hasn't heard that term before, PostGIS is probably the most popular geospatial, like open source geospatial extension in the world. It's an extension to Postgres, which is another database, and it allows users of Postgres to do geospatial operations within Postgres. Similar to PostGIS, SingleStore has a bunch of geospatial operations embedded, and so we can look at that on the docs, geospatial. And so you can look at all of our geospatial operations, and these are all built in. So without any additional extensions, you can just pull SingleStore, start using it, ingest geospatial data, and do pretty complex geospatial analytics. The analytics that we've built are specifically the things that are really, really hard to do at large scale. So things like find all the points in like some arbitrary polygon across billions of points, stuff like that. And so in general, SingleStore, our geospatial extensions are pretty flexible. But sometimes you might want to have some really specific function that we didn't happen to build in. And so with WASM, you can essentially add a function that does exactly what you need. You could basically add a function that says, well, I need to find like triplet points. Like I want to find like 3 sets of points that have some property. And so you can write a WASM function that can sort of do that without needing to have SingleStore add that as a built-in, right? So another engineer, as I was saying, in the hackathon added a bunch of PostGIS functionality to SingleStore through WASM, right? So the benefit is that we no longer need to be the curators of every single function that goes into the engine. We're empowering our users to basically take whatever they want from the open source community and add it to the engine really easily. And stay tuned in the coming sort of weeks and months for more examples on our GitHub repo of different things you can do with WASM. We're really excited to see what people can do.
That's
So
fantastic.
that's the WASM side. Do you have any questions on it?
No, I think, I mean, that's probably a good segue to talk a little bit about those repos, like where you find those repos. And I think you've got a project from this hackathon that's already up in the SingleStore org there.
Absolutely. Well, okay, so we'll talk about a couple on GitHub. So the first thing on GitHub, as Dominic was referring to, is we have SingleStore Labs. This is github.com/SingleStore Labs, and this is a organization where we have a whole bunch of open source code. We have lots of really cool stuff here, starter projects for different languages, really cool innovation projects that we're working on, a lot of WASM-based stuff. So this is the place to go if you're interested in SingleStore open source. We have also a lot of demos here, so it's a great place to sort of see how SingleStore can be used. I'll talk about Numeromancy, I guess now. Yeah, so one of the projects that we had in the hackathon that I worked on is called Numeromancy. And Numeromancy is the idea of doing a full like machine learning training and like end-to-end training of a machine learning model within SingleStore. And so the specific model that this supports is a argument minimization sort of model with logistic regression. So essentially, if you actually open up the open source repo and you follow the sort of README, there's like a step-by-step approach. It will actually train a model that predicts cancer remission in patients. And this entire process happens inside of SingleStore. And it uses WASM in 2 ways. One is it uses WASM to actually implement the cost function. So the actual training process is a series of aggregate scans over all of the data in SingleStore, producing sort of the current cost based on some parameters. And then essentially we optimize those parameters to find the best predictor for cancer remission. And then once we feel like the predictor is stabilized, we found sort of the best predictor that we can based on the model, then we actually output another WASM function which implements the inference entirely in the engine. And so now you have this nice little WASM function inside of SingleStore, which you can use to predict cancer remission. And that's a really cool use case of WASM. We've used it sort of in 2 different places. So that's Numeromancy. Another thing I want to draw your attention to is a project that just went live today. And so this is SQL Formatter. SQL Formatter is an open source project that can essentially format SQL. So if you have some blob of SQL that you want to format, so for example, they have a really cool demo here. So in this demo, they have some really ugly looking SQL, and then you run it through SQL formatter and it outputs this nice looking SQL. And it has a lot of like properties. So you could basically say like, I want to have some particular format that you want. The thing is that every SQL dialect is slightly different, and SingleStore has its own sort of peculiarities that's different from other SQL dialects. It's mostly MySQL compatible. I would say 99% MySQL compatible, but there's a couple little things here and there that make it not perfect. In addition, we have a bunch of additional functions that MySQL doesn't support. And so one of the other hackathon projects, which is really cool, is this merge that is still on the head of SQL formatter, which is that one of our engineers actually built SingleStore support into SQL formatter. And so now you can basically just install SQL formatter directly from NPM in your JavaScript project and directly start formatting SQL. And I believe that this project will actually make its way into our SQL editor in the portal, so that as you're writing SQL, will be able to format it for you. So this is just another idea of the value of hackathon.
That's super cool. I mean, I think for developer experience, having readable code, readable SQL is super important, and especially if you're coming from another sort of dialect. I mean, as you said, each database has a slightly different sort of dialect, and there's a little bit of a learning curve, and this helps to automate and sort of, make it more easily readable, but also it could be a learning tool in some ways too, as sort of the cheat code for picking up a new SQL dialect, or at least the SingleStore's dialect.
Exactly. So I guess, Akmal, if I want to turn it over to you to talk about the last hackathon project, and I think you have it queued up to show.
Yes, thanks, Carl. So let me have a look and just get the window there. So this is dark mode. Okay, and well, you're not looking at dark mode yet. Okay, that's what's coming. But let me just have a look here.
What are we looking at here? Tell us, this is the portal, right?
It is, yes, that's right, Dominic. So I'm logged into portal.singlestore.com. So this is my account here. And on the left-hand side, I've got a range of operations that I can do. I mean, there's things I can pull up. For example, SQL editor here. As you can see, I've got some SQL code in there that I used actually just a couple of days ago. And one of the options that we have available now on the extreme left-hand side, right at the bottom there, is settings. And so if I click on settings here, and here, account theme, currently it's set to default to system, but I can choose light and dark. So if I switch to dark, there we go, dark mode, voila.
Wow, just in time for Halloween. I love it.
Yes, brilliant.
SingleStore Dracula, that's nice.
Yeah.
Very cool. Well, I think that's a lot easier on your eyes. I mean, depending on what's your...
Oh, yes, definitely. And I think, I mean, it depends, because I think some colors are great for presentation, some much better for coding. And so this could be a little bit easier on the eyes, I think, especially if you're going to write a lot of code and run it. But this is great for me as well. So I'm an eye owl, so I think it's going to help me a lot.
Yeah, I could see where this could go in terms of colorization, like themes like Dracula and other things. If you want to have your own color theme, I could see this being extended that way in the future, possibly. Very cool. Well, let's now hand it back to Carl to talk about the WASM space program. There is, as he cues that up, you will find that on our YouTube channel. You'll find Carl's full 10-minute walkthrough. I'll post a link to that in the chat here in a moment. But I think it's going to be something you're going to firstly have a lot of fun playing with, and then have a lot of fun diving into the open source code to understand how it's constructed, which features it uses. It's pretty remarkable. And with that intro, Carl, I'll hand it back to you.
Sweet. Thanks, Dominic. Okay, so WASM Space Program, let's just start with what it is if we were hypothetically a customer of this hypothetical game. So WASM Space Program is a massive universe simulation that is running entirely inside of SingleStore. That's like the high level pitch. And within this simulation, there are many solar systems. And so this is the live demo, by the way. This is something that is running online. It's been running for a couple of weeks, and it's been processing about 2.8 million writes per second. And that's been going on nonstop for a couple of weeks with no interruptions. And what are these 2.8 million writes doing? Well, these 2.8 million writes per second are simulating this entire universe. Every single agent, so agents are essentially like spaceships that are driving around this universe, interacting with various entities, are being simulated per second. And so that the idea of Wasm Space Program was to see how we could build something like this and push down as much logic as possible into SingleStore. And so if we jump into one of these solar systems, so all of these little orange dots on the screen are solar systems. If I jump into one of them, what you're going to see on the screen is a bunch of new objects. So each of these objects represent a couple different types of entities. These objects that are running around the screen right here that are moving around, those are spaceships. And spaceships each have a particular AI behavior that drives what they want to do. So this particular spaceship here has the battle strategy. And so in general, it's going to take on sort of fights with other spaceships, even when it might not be the most opportune. Like it's just going to be a little bit more aggressive in general. Other spaceships like this one over here has the flee strategy. And so its general premise is to try to run away from fights as much as possible. And so the battle strategy and the flee strategy often get into weird chases with each other. But the idea is that, well, within this solar system, there's a bunch of agents flying around and doing their own thing. There's also these energy nodes. These green things are energy nodes. They are static, and they each have a certain amount of energy. And a spaceship can essentially spend its turn on the energy node and consume the energy from it. And in this case, these two spaceships are both fighting over these energy nodes. So you can see down in here in the top bottom left, we have like a sort of stack of objects on this cell. There's two spaceships which are fighting over the energy node, and it looks like this spaceship is likely to win. And so this one's about to blow up. If we give it a couple seconds here to lose the battle, we're going to see probably an explosion. So the idea is that all these spaceships are being simulated in real time across the entire simulation, and the whole thing is running inside one massive single store transaction. And so every second, single store transaction starts, and then essentially there's a series of update and insert queries, which like migrate the entire universe from one state to the next. And all of this is done atomically. And that's what makes this just absolutely, from a database nerd perspective, is really, really cool. And so, yeah, I can basically jump into any other solar system. So I can just go to like a random solar system over here, and some other things are happening, right? So there's no, just because I'm looking at this solar system doesn't mean that all those other solar systems aren't running. And anyone else who opens up the Wasm Space Program right now is looking at the exact same state as I am. That's the really cool thing about SingleStore, is that it's very scalable. And one of the ways we make it even more scalable is by leveraging workspaces. And so the Wasm Space Program actually allows you to switch between multiple workspaces up here in the top left. So I can switch over to workspace 1, at which point I see the exact same thing. Well, that wasn't that interesting. What happened? Well, what happened is that I just moved all of the network communication from my game client, which is the browser, between two different single store clusters. But because of how workspaces work, all the data is transparently replicated in real time. And so even though I just switched between two compute clusters, I see the exact same information, right? So I can switch back to workspace 0, and everything pretty much looks the same. And so by using multiple workspaces, we make sure that Wasm Space Program can scale really well with large concurrency. Because we've used workspaces to separate the read workload from the write workload, which runs in yet another workspace that's completely independent from the read workload, we can guarantee that the write workload can proceed with almost no contention. It can just execute consistently every single second and iterate the entire state forward. Whereas the write workload, since we can have as many workspaces as we want, there's some limits in the managed service, but the fundamental premise is that we can basically scale this very, very easily to handle whatever concurrency level that we need. So that's the high level idea of Wasm Space Program. I can open up this architecture diagram, which is also in the demo. So if you go to the link, you can see this yourself and play with it. And we can talk a little bit more about this, but I'll open up to questions. There's questions. I think Dominic and Akmal have questions, but also if anyone in the audience has questions, feel free to ask it. As long as you're on, I think, Twitch or YouTube, we'll be able to see those questions here. And if you're on Twitter, you can just like tag one of us and we'll try to find it.
Yeah, LinkedIn works too. You can post there as well.
Oh, and LinkedIn, yeah. Do you guys have any questions?
I'm curious, like, what are workspaces? We mentioned that a little bit earlier. What are they, and how do they help in this demo application?
Great question. So workspaces is the idea of essentially being able to completely isolate compute from one another, but share the same database. And so in this diagram, we see this stack of workspaces. Each of these boxes, the writer, the reader one, reader two, reader three, each of these boxes you can think of as like an independent single store cluster. However, because they're all connected to the same database, which is also replicated to object storage, they're all able to run read operations on any of the data in the database. With workspaces, you can only have one workspace have write access to a database. So essentially, we have like sort of write once, read many architecture. So we have one workspace in the WASM space program is essentially the writer to the underlying database. And that is where we're running the turn execution. The benefits of workspaces is fundamentally to separate different parts of your workload or different sort of concerns. So a couple different examples. Like the first example is that with workspaces, I can have, like in this example, I can have a write workload, a heavy write workload running independently from read workloads. So that can help me handle concurrency, for example. But another case could be like, let's say you have 3 different teams in a company all working with their own applications. So you have 3 applications running on SingleStore. You could have 3 different workspaces, one per application, which owns their own database. So you now have 3 different databases. But we can actually share read access to all of those databases to all the other workspaces. So you could end up with like this sort of triangle where every application is able to read across all of the databases, but they're only able to write to their database. And so each of the teams can be confident that no one is messing around with their database and no one is messing with their write performance either. But you can still essentially share data in that way. So Workspace is a very flexible architecture to sort of solve a lot of these interesting sort of large scale organizational problems.
That's great. And we've got a question here that's on the screen there from Brian Bowman. What's the single store hardware configuration for this, or at least for the
Great
demo?
question. Let me go ahead and just give me a second and I will pull it up. All right, let me share this. Actually, I'll just share the whole window. That's easier so I can bounce around. All right, Dominic, if you can throw that on the screen. So this is a SingleStore, the portal to our managed service, and this is the entire cluster that's running the workspace or for WASM Space program. The core write execution is running on an S32, which is a pretty large cluster. The write operation, in order to be able to maintain 2.8 million writes per second over indefinite period of time, we need 2 things. We need quite a lot of compute to be able to run this. The write operations are not cheap. Like each of these write transactions takes about 850 milliseconds to execute. So we're quite close to that sort of like 1 second boundary. And during that write operation, we're running, I try to remember the exact number. I want to say that it was, so there is 2.8 million write operations. And out of that, it's 3 WASM invocations per write operation. So it's something like 6 to 7 WASM invocations per second. And each one of those WASM invocations is processing quite a bit of state. So if you think about one of those spaceships, that each spaceship, in order to be able to execute and figure out what it wants to do to run its AI, we need to actually look at the entire neighborhood around that spaceship. So we have to look within a certain number of cells around each spaceship to be able to calculate for that spaceship to have enough information to decide what it's going to do, whether it's going to be running away from a battle or going towards an energy node or just exploring. Right. So essentially, the write workload is quite expensive, and I can go into more details about how we're using WASM there. The read workload is broken up between currently 2 different workspaces, which are these different workspaces, and they're quite small. They're S4s. These could actually be even smaller. A lot of the read workload is actually quite sharded, like it's quite concurrent friendly, because you're only ever looking at a single solar system, right? So as the reader, so as like this, I'm a reader right now, I'm using a client, so I'm only looking at the data right here. And so since SingleStore is distributed, even a relatively small cluster can scale to a very large amount of concurrency because I'm only querying a very, very small fraction of data. So Brian, hopefully that answers your questions. Thank you.
Yeah, it strikes me too. Like, this allows you to, on a single store database, you can have logical separation, and you can apply that in all different kinds of ways. It's interesting how you've applied it here for these AI agents for reading state, writing state. It seems like there's lots of ways to apply this workspaces to separate. Like if you had a set of microservices, you wanted them share the same database and schema, but you want separation by sort of, a lot of these APIs may just be reading data, and you want to scale those and have them separate, and it could be intermittent. There are different APIs that might just be fetching single values. Some of them might run analytic functions. You could segment or organize them by the shared kinds of workloads, and then in that way, with the same shared schema, which you could have a different logical way of separating schema, you've got now another level of flexibility in how you design your application. It just seems like there's a ton of applications for workspaces here.
Absolutely. Yeah, it's one of the most powerful features we've ever built, just in terms of added flexibility and the ability to scale to larger and more complex workloads.
So the other thing you pointed out in that architecture diagram is the data API. So you said that the entire game is running in database, and you've got stored procedures running these, and the Rust compiled to WASM is running these agents. How are we, when we go to that link on the program just to play the game through the browser, how does that work? What's running in the front? How does it connect to the back end?
Yeah, that's a really, really good question. So if we see this, going back to the architecture diagram, what Dominic sort of mentioned, we see this data API here, which says HTTP. And the idea here is that the game client is actually written entirely in JavaScript and runs inside your browser. There's no middle tier. There's no server between the browser and SingleStore itself. Actually, it's so powerful that since we're connecting directly to SingleStore over the data API, I can actually just run arbitrary queries. So here's a SQL query. I can just change this column name, or let's just say let's look at this. So if I run this query, I get back the number of ships that are alive for each of the different strategies for each of the different AIs, right? So like, let's say that I didn't prepare an idea query, but I could just rename this column like as food, for example. And so we can see that, like, oh, I can't actually do that because I'm referencing it. 1 second. Foo, ships, foo. Okay. So I just like changed this query arbitrarily. There's no backend server that I had to modify to do that. So I'm doing this entirely in just the JavaScript. I'm running queries, and those queries are going to SingleStore, executing and returning the results back as JSON without additional sort of backend APIs. This is an extremely powerful model for building modern apps. Because SingleStore has authentication built in, we can actually authenticate against the server. We can do pretty complex authentication schemes as well. And those are also going to become more complex in the future. So we'll be able to handle really powerful applications on top of our data API. But also just from a developer productivity perspective, when I was building the WASM Space program, if I wanted some additional data from the database, or to reshape the data in a particular way, it was as simple as just writing a new query that did what I want. And so I can actually go to GitHub, and I can open up the WASM Space program. There's a lot of WASM stuff. 1 second. WASM Space program. And what we can do is we can actually just look at the web. So this web folder contains the entire game client. So this entire JavaScript program that we've been looking at is contained in this directory. And if we go into source and then data, you can see that the client is literally just a bunch of JavaScript that runs essentially fetch operations. So if we look at like the core fetch operation, this function here, fetch endpoint, is literally just using the built-in browser fetch function to essentially query SingleStore. So this endpoint here hits SingleStore directly. which is really just like mind-blowing for a JavaScript programmer, which I am. I'm saying that from the perspective as a JavaScript programmer. So if I go, for example, to queries, you can actually see like the entire operation of this demo. Every single piece of data and every single thing that happens in the demo is driven by one of these query functions. And these query functions literally just have embedded SQL. I've written like a nice TypeScript wrapper around it so that everything is completely type safe within this module. And I can literally just run some arbitrary query with some complex analytics and get back exactly what I want. An example of that is if I see, let me see here. Well, just an example of that is like, for example, query entities by entity location. So I'm essentially taking in an entity ID and injecting that into this query and running like a pretty complex query, which finds all the entities that are sort of in a stack. So they're like on top of another entity. And so that's how we are able to render when I click on an entity, if I can find one that's not moving around too fast. If I click on an entity that's sitting on a stack of things like this one, this stack here is literally just this function. There's no other code. It like runs this query and then it renders the result as this stack of DOM nodes, right? So it just makes building applications in JavaScript that are pretty complex and data attached just very trivial.
That's really cool. I think this is like something you could spend hours and hours diving deep into the game, but also experimenting with a little modifications to the code and extending. Let's share where folks can find this. This is where you'll find the application that Carl's been demonstrating here on our SingleStore Labs GitHub. It gives you the whole link to play the game, dive into that. We'd love for folks to like play with it, come hit us up in the forums, ask questions about it, or just reply in the on the socials where we are. Gosh, guys, this is fascinating. I could spend like the full hour talking about with this, but I think we should wrap up here. I'd encourage everybody to go check these out on our, like I said, on our GitHub. Go to our YouTube channel, find the recent updates from the summer launch last month, and join the forum. And you can try SingleStore for free if you go to. It's pretty easy, singlestore.com/free. You can download that and deploy it locally on your laptop and run that, or run a cloud trial. And so we provide free credits for you to go and follow along there. Guys, any concluding thoughts?
Yeah,
I hope everyone goes.
Dominic, Carl, is there an end condition for your simulation? All the ships get blown up?
Oh, good question. So currently the simulation actually is continuous. So there's a spawning logic, which basically continuously spawns ships. Ships die extremely frequently in the simulation, so it's needed to like replenish the system.
Yeah, gotcha. Thank you.
Cool. Well, awesome. Next month, join us. As I said, we've got Aaron Francis joining us to talk about the Laravel driver, and we'll have more updates for you then. So until next time, thanks, everyone.
Thanks, everyone.